Now we'll talk about using trigonometric functions. So I think I missed a word here. It's probably how to find the lengths of the remaining sides of a right triangle given the length of one side and the measure of one acute angle. For each side, select the trigonometric function that has the unknown side as either the numerator or denominator. The known side will in turn be the denominator or the numerator. Write an equation setting the function value of the known angle equal to the ratio of the corresponding sides. Using the value of the trigonometric function and the known side length, solve for the missing side length. Okay, so here's one that we have. And it says find the unknown sides of the triangle. I wonder if I'm missing some piece of information. Okay, so I don't think I am. I think I have it all here. So I'm going to start with the angle I know and the side I know and what function deals with those two. I'm going to go with sine. So if I go sine 30 degrees equals opposite, which is 7, over hypotenuse, which is c. I know sine of 30 is 1/2, so 1/2 is 7 over c. So if I multiply both sides by c, 1/2 c equals 7. So then I can multiply by 2. So c would equal 14. So now we know two sides. Now we could use the Pythagorean theorem, or we could use the knowledge of this 30, 60, 90 triangle as well. You remember we saw earlier that if this side is s, this side is 2s, and this side is the square root of 3 times s. So we could say, well, s must be 7, so that a must be the square root of 3 times 7, or 7 root 3. We could also use a Pythagorean theorem and say a squared plus 7 squared equals 14 squared. So a squared plus 49 is 196. Then subtracting 49 from both sides, a squared would be equal to, I have to borrow, I'm going to get a 8. 16 minus 9 is 7. 4, so 147. That doesn't look so great, but a squared, it would be, you could call this 3 times 49. And then you'd have a would be the square root of 3 times 49. So a would be 7 root 3. Okay. And I think I'm going to go ahead and just continue on this video for the last part, applications of trig functions and angles. So when you're at the top of something, from the horizontal and you go down, that's an angle of depression. If you're on the ground and you're looking up, that's an angle of elevation. So how to measure the height of a tall object indirectly. Make a sketch of the problem situation to keep track of the known and unknown information. Lay out a measured distance from the base of the object to the point where the top of the object is clearly visible. At the other end of the measured distance, look up to the top of the object. Measure the angle the line of sight makes with a horizontal. Write an equation relating to the unknown height, the measured distance, and the tangent of the angle, the line of sight, and solve the equation for the unknown height. So here we go. To find the height of a tree, a person walks to a point 30 feet from the base of the tree. She measures an angle of 57 degrees. Measure the line between the line of sight and the top of the tree. So find the height of the tree. So what we really have is a triangle looks like this. So this is 57 degrees. This is 30, and this is the height. So given this angle here, what function deals with the opposite and the adjacent side? That'd be tangent. So tangent of 57 degrees would be h over 30. So we're solving for h, and I'll just multiply both sides by 30. And those would divide out. So h would be 30 times tangent of 57 degrees. And I get my fun-filled calculator out here. And I got to make sure it's in degree mode, which it's not. And I just type in 30 times tangent of 57. And the height of the tree would be 46.1959 feet. They don't say if they want it in, to the nearest, 2 decimal places or whatever. So there you go. There are other tricks I've used with my scout troop when we've tried to find heights of trees, because they aren't sophisticated at that point when I taught them to be able to do this. Besides, we're looking for rough approximations when we do that. But happy to share those fun field skills with you sometime. Okay, that's it for this section and for this chapter. So there we go.